This is SpaceTime, Series 21, Episode 77. Coming up on SpaceTime, echoes of a galactic collision involving the Milky Way. A satellite successfully removes space junk from orbit. And the strongest controllable magnetic field ever produced. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered ripples in the Milky Way galaxy, most likely caused by its cannibalization of the Sagittarius dwarf galaxy. Galaxies grow by merging with or cannibalizing other galaxies, and our own galaxy, the Milky Way, is doing that right now with several small satellite galaxies. Gravitational tidal star trails are extending into the Milky Way from both the large and small Magellanic Clouds to nearby dwarf galaxies. These gravitational tidal trails are caused as stars and gas are drawn off the Magellanic Clouds by the massive gravitational force exerted by the Milky Way. But an even bigger event is occurring right now on the far side of the Milky Way, where our galaxy has been cannibalizing the Sagittarius dwarf galaxy. Now, observations by the European Space Agency's Gaia spacecraft has discovered that the Milky Way itself is experiencing gravitational effects from that interaction. Gaia has found millions of stars in the disk of the Milky Way which appear to be moving like ripples on a pond. The event which caused these ripples occurred sometime in the last 300 to 900 million years. The pattern of movement was revealed because Gaia not only accurately measures the positions of more than 1 billion stars, but also precisely measures their velocities on the plane of the sky. And for a subset of a few million stars, Gaia was able to provide an estimate of the full three-dimensional velocities of those stars, allowing a study of stellar motion using the combination of position and velocity, which is known as phase space. In phase space, stellar motions revealed an interesting and totally unexpected pattern when the stars' positions were plotted against their velocities. The study's lead author, Teresa Antuja from the University of Barcelona, says she couldn't quite believe her eyes when she saw the effects on a computer screen. One shape in particular caught her attention. It was a snail shell-like pattern in the graph that plotted the star's altitude above or below the plane of the Milky Way galaxy against their velocity in the same direction. It was a pattern that had never been seen before. And the reason they hadn't seen it before was simply because the quality of the data coming from Gaia is such a huge step up from what was previously available. The authors described the stellar motions as being the same sort of effect you get when you throw a stone into a pond, which then displaces the water as ripples and waves. But unlike water molecules, which eventually settle down again, the stars retain a memory that they were perturbed, and this memory is found in their motions. After some time, although the ripples may not be easily visible in the distribution of the stars, they're still present when you look at the star's velocities. So, the next question was what had hit the Milky Way to cause this ripple-like behavior in the stars? It was then the authors recorded studies on the Sagittarius dwarf galaxy. Sagittarius dwarf contains a few tens of millions of stars, which are currently in the process of being cannibalized by the Milky Way. Its last close pass to our galaxy wasn't a direct hit, but it came awfully close. Close enough that its gravity would have perturbed some of the stars in our galaxy, just like a stone being dropped into water. The clincher was estimates of Sagittarius dwarf's last close encounter with the Milky Way, which took place between 200 million and 1 billion years ago, which exactly matched the time frame for the beginning of the snail shell-like pattern. So far, however, the association of the snail shell feature in the Sagittarius dwarf galaxy is based simply on computer models and a general analysis. So the next step will be to scrutinize the phenomenon in more detail. The authors want to investigate the galactic encounter as well as the distribution of matter in the Milky Way by using the information contained in the snail shell shape. Of course, this encounter between the Milky Way and another galaxy won't be the last. In about 3.7 billion years from now, the Milky Way itself will be consumed, cannibalized and torn apart when it collides with the even bigger Andromeda galaxy, M31. I'm Stuart Gary. You're listening to SpaceTime. Scientists have successfully used the satellite to remove space junk from orbit. The experiment using the uncomfortably named Removed Debris satellite successfully deployed its onboard net technology to snare a deployed target, simulating a piece of space debris. The test involved a CubeSat called DebrisSat-1, deploying a balloon meant to simulate the space junk. The Removed Debris satellite then captured the target in a net and then maneuvered the target in such a way that it will eventually fall into Earth's atmosphere and burn up. The demonstration marked the first time space junk's been actively removed from orbit. Removed Debris was developed by the University of Surrey. While using a net to grab a piece of junk floating around in space might sound pretty simple, you've got to remember the effects of microgravity and inertia dramatically complicate matters, especially when you're travelling at orbital speeds. In fact, the complexity of using a net in space to capture a piece of debris took many years of planning, engineering, and coordination. Developing the net technology to capture space debris took 6 years alone of testing in parabolic flights, in special drop towers, and in thermal vacuum chambers. In coming months, the Removed Debris satellite will test more active debris removal technologies. These will include a vision-based navigation system in which a second CubeSat, called DebrisSat-2, will be released, and the Removed Debris satellite will undergo a series of maneuvers using both LiDAR and optical cameras to analyse and observe potential pieces of debris. A third experiment will deploy the first harpoon capture technology in orbit, when a harpoon connected by a tether will be fired towards a target attached to an arm extending from the Removed Debris satellite platform. And a final test will see a drag cell deployed by the satellite, acting as a sort of air brake in the rarefied environment of near-Earth space. Yes, there are a few molecules of atmosphere up there, enough to slow down the Removed Debris satellite just a smidgen, bringing it down from its 400-kilometre high orbit into Earth's thicker atmosphere, where it will burn up in re-entry and be destroyed, bringing its 18-month mission to an end. The Removed Debris satellite and its two CubeSats were launched aboard the SpaceX Ceres-14 Dragon cargo mission to the International Space Station. The satellites were then deployed from the orbiting outpost COBE module using the space station's Canadarm2 in June. In fact, the 100-kilogram Removed Debris spacecraft is the largest satellite so far deployed from the International Space Station. But the problem of space debris is also a large one. The US Space Surveillance Network tracks over 40,000 objects, and they're just the ones big enough to be seen. In fact, it's estimated there are some 7,600 tons of space junk in and around Earth orbit, with most moving at least 28,000 kilometers per hour, and some moving as fast as 60,000 kph. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
Now, Fred, we're going to talk about space junk. There's so much of it, and it has caused problems in the past, having to move the International Space Station to avoid a direct hit. There have been issues with flecks of paint causing problems with the space shuttle. And everyone agrees, the international space community, that something has to be done. And now they're trying to figure out ways of removing debris from space, everything from harpoons to nets. So it's back in the news again. What's happened?
It's a satellite built by the University of Surrey and various associates, designed to test some different technologies for getting rid of space junk. It's a big problem. As you said, I think it's about 22,000 bits of space debris that are tracked, and that's down to a size of something like 4 inches or 100 millimeters. But then below that, there are probably millions of bits of stuff. And one estimate that I read recently is that there's about 7,500 tons of space junk up there, which is probably about right when you think of all the launches that have been made and the fact that there's probably some big rocket bodies up there and things of that sort all tumbling around in space. It's a problem because if you get 2 bits of space junk colliding, then you suddenly have this knock-on effect, because that creates much more debris, which can then collide with other things. And before you know where you are, space is actually, inaccessible. And that's the doomsday scenario as far as space travel is concerned. So this is a first step in trying out technologies that might help us to deal with the space junk problem. And what the University of Surrey has done is sent a spacecraft up. I think it's about the size of a fridge. It's quite heavy. I remember them, when we talked about it being ferried up to the International Space Station, we realised that it was quite a massive object. I think it's getting 3/4 of a ton or something like that. If I remember rightly, I might be misremembering, but that's what comes to mind. So this spacecraft has the wonderful name of Remove Debris. What they've done is tried out the first of their technologies for, eliminating netting space junk is the way to put it, because that's exactly what it is. This is a net which can surround a piece of space junk and tether it basically to a sort of parent spacecraft, which then itself re-enters and drags the space junk with it to burn up harmlessly in the atmosphere. So we've seen now footage that's come back from the University of Surrey showing the net being deployed. And the net is really quite spectacular. There's a lovely image of the net as it's stowed in its firing position. That was obviously taken before the spacecraft was launched. It just looks like a bowl of spaghetti. But then it's very cleverly arranged, a very cleverly designed net, so that when it's fired outwards, it has sort of multiple lobes, which basically enfold around the piece of space junk that you've got there. And what they've done is they've taken up one of these little nanocubes, these bread loaf-sized spacecraft, and used that as the target. So they dumped that thing out, made sure it was spinning, because they nearly always are tumbling end over end, these bits of space debris. And then they snared it with the net. Yeah. And actually it's worked. And it's a very nice piece of work.
Yeah, I've watched the video. It's sort of like casting a net to catch fish. Or a spider web type of effect.
Yep.
And
it is.
You can see the satellite spinning, and the thing just wraps itself around the space junk and completely bottles it up. It's really impressive.
Very much so. So there's obviously some clever thinking going into the exact design of the net. And then in the real life scenario, that net will, as I said, be attached to a sort of mothership, which will be the thing that tows all these bits of space debris back down into the atmosphere and burns them up.
What sort of speeds are we talking about in terms of this sort of capture?
Do you mean the orbiting speed? So this is all happening at about 8 kilometers per second. 7.8 kilometers per second is the orbital speed at about 100 kilometers above the Earth's surface. And it's not much less than that as you go higher. Yeah, it's pretty remarkable stuff. And what I like about this is it highlights the problem and that there is an issue, and also highlights the need for all new satellites to make sure that there is a way of bringing their satellite back down to Earth when its life has ended, or anything else that fails in orbit. You want to have a mechanism that will let you get it down quickly so it doesn't become an orbiting hazard. That is not yet part of the space rules and regulations, but there are hopes that it will be. It is for geostationary satellites. If you launch a geostationary satellite, that's up much, much higher than we're talking about here. They're 36,000 kilometers high. You have to have a way of putting your spacecraft into what's called a graveyard orbit, one that will not endanger any other spacecraft at the end of its life. And that's been in place for quite some time. But the same is not true for lower ones.
Or could you just slap on an extra engine, just unused, when it's finished its life, fire it up and send it off into oblivion?
Yeah, effectively that's what you do. I mean, the problem is you never send it in oblivion because you're always in orbit around the Earth, unless you've got something that's capable of taking it beyond the escape velocity of the Earth. That means big hardware, that means big rocket motors. Yeah.
So I was dreaming a bit there.
Dream on, because the next stage in removed debris, we will no doubt talk about it. They've also got a harpoon, which is very much like the old, kind of whaling harpoons. The idea with this is that you grab your defunct spacecraft by smashing into it with a harpoon. It's got little lobes on it that open up so that you can then drag the thing back once again and drag it back down into the atmosphere to burn up. That is yet to be tested. We will await the results of that with great interest.
They both sound quite feasible, and as this test proves, can work. But I would imagine the removal of space junk is certainly a long-term prospect.
Yeah, doing it one at a time certainly is. That's right. So much of it.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. Physicists have generated the strongest controllable magnetic field ever produced, and the field was sustained for longer than any previous magnetic field of similar strength. The research could lead to powerful new investigative tools for materials scientists, and may have applications in fusion power generation. Magnetic fields are everywhere, from the smallest elemental particles to the large-scale cosmic structure of the universe. And you'll find them in everything from the Hubble compass through to the world's largest atom smashers. In fact, science's ability to understand and control these fields have crafted much of the modern world. So the ability to create stronger, controllable magnetic fields will advance many areas of science and engineering. And that's where scientists with the University of Tokyo come in. They've developed a large, sophisticated new device in a purpose-built lab capable of producing the strongest controllable magnetic field ever used, using a method known as electromagnetic flux compression. At 1,200 teslas, that's a unit of magnetic field strength, the generated field dwarfs almost any other artificial magnetic field ever recorded. Mind you, it's not the strongest overall. Back in 2001, physicists in Russia produced a field of 2,800 teslas, but theirs was an explosive method which quite literally blew apart their equipment, and the magnetic field was uncontrollable. But these experiments usually only last a few nanoseconds. The research with the University of Tokyo's magnetic field lasted around 100 microseconds, considerably longer, although in reality it's still 1,000 times less than the blink of an eye. It is possible to create much longer-lasting magnetic fields, but these are only a few hundreds of teslas in strength. The goal of this research is to get over 1,000 teslas reliably and controllably. The project's lead scientist, Shoju Takayama, says magnetic fields above 1,000 teslas opens up some interesting possibilities for research, allowing study into the motion of electrons outside the material environments they're normally in. This would allow scientists to explore new kinds of electronic devices and new research into fusion power generation. And that's important because fusion power is the most promising way to provide clean energy for the future. One way to produce fusion power is to confine plasma, a sea of charged particles, in a large ring called a tokamak, or a large wobbly-looking ring called a stellarator. In both cases, the aim is to extract energy from it. However, this will require strong magnetic fields of the orders of thousands of teslas for at least a few microseconds, which, when you think about it, is tantalizingly similar to what this device can produce. I'm Stuart Gary. This is SpaceTime. Well, after a series of delays due to bad weather and rocket engine issues, the Japan Aerospace Exploration Agency, JAXA, has successfully launched the supply ship bound for the International Space Station. The HTV-7 supply ship was launched from the Tanegashima Space Center south of Tokyo aboard an H-2B rocket on a 5-day flight to the orbiting outpost.
7, 6, 5, 4, 3, 2, 1. Liftoff of the HTV-7 vehicle making its way to the International Space Station right on time, carrying more than 5 tons of equipment, including new batteries for the space station's electrical power system and equipment that will help increase the International Space Station's science capabilities.
We have a liftoff of the H-2B launch vehicle number 7 with crew 7 aboard from the JAXA Tanegashima Space Center at 2:50 to 27 a.m. Japan Standard Time on September 23, 2018. Following liftoff, the operation control of the launch vehicle has been switched from the blockhouse to the range control center.
Just over 1 minute into the flight of the HTV-7 transfer vehicle to the International Space Station. At the 2 minute and 6 second mark, we will see the solid rocket boosters, the 4 solid rocket boosters at the base of the H-2B rocket, separate from the rocket, having completed their duty in getting the rocket off the launch pad and on its way to space.
The H-2B flight is on course. The Tanegashima station is tracking the launch vehicle very well. The SRBAs have burned out.
Now 2 minutes and 9 seconds into the flight, those solid rocket boosters separate.
Separation of the first and second pairs of SRBAs.
Next up, we'll see the rocket fairing separate. That will be coming up at 3 minutes and 38 seconds into the flight. Launch took place right on time at 12:52 p.m. Central Time from the Tanegashima Space Complex. At that time, the space station was flying about 262 miles above the South Pacific Ocean.
The combustion of the first stage engine, attitude control, and flight trajectory are all nominal. The H-2B flight is on course. Current altitude is about 95 kilometers. Velocity is approximately 2 kilometers per second.
Rocket fairing separation and hearing confirmation that everything is going nominally and that those fairings separated just as planned. Next up, at 5 minutes and 43 seconds into the flight, we'll see the main engines cut off.
The combustion of the first stage engine, attitude control, and trajectory are all nominal. The H-2B flight is on course. Current altitude is about 147 kilometers with the approximate velocity 3.7 kilometers per second. The first stage engine cut off.
And there is the main engine cutoff for the H-2B transfer rocket carrying HTV-7 into space, coming right on time at 5 minutes and 43 seconds into the flight. We're now just over 6 minutes into the flight. We also saw the separation of the first and second stage, and the next milestone will be the second stage ignition. And actually,
the H-2B has entered the range of the JAXA Guam station.
Ignition occurred just as planned. The total burn time will be 8 minutes and 25 seconds. It will last until 14 minutes and 26 seconds into flight. So the HTV-7 now being powered further into space towards the International Space Station by the second stage of the H-2B launch vehicle. That second stage is 36 feet long, and again, the burn time is a total of 8 minutes and 25 seconds.
Once it arrives, the HTV-7 will be grabbed by the space station's robotic Canadarm and then attached to the Harmony module's Earth-facing docking port. The HTV-7 is carrying some 6,200 kilograms of water, food, supplies, equipment and experiments, including 6 new lithium-ion batteries weighing some 1.9 tons. 2 extravehicular activities, or EVAs, that's NASA speak for spacewalks, will be needed to replace the existing nickel-hydrogen batteries with their new lithium-ion counterparts. The cargo ship's also carrying 2 new science and research racks loaded with experiments. There's a new prototype life support system producing oxygen from water using electrolysis, a life sciences glove box which will be installed in the Kibo module, a loop heat pipe radiator technology demonstrator system, a small satellite orbital deployment system, and 3 CubeSats which were developed by universities in Japan and Singapore. Other experiments aboard the supply ship include a new sample holder for the electrostatic levitation furnace, a low-temperature protein crystal growth experiment, and a study looking at the effects of microgravity on bone marrow. There's also a small cone-shaped re-entry capsule. It's designed to demonstrate re-entry technology and cargo recovery from the space station without needing a full-size cargo ship. After the HTV-7 departs the space station early next year, the capsule will separate from the spacecraft's hatch for a parachute-assisted splashdown off the coast of Japan, from where, hopefully, it will be recovered. India has successfully launched a pair of scientific research satellites as part of a joint Australian-UK project. The 44-metre-tall 4-stage Polar Satellite Launch Vehicle, or PSLV, blasted off from the Satish Dhawan Space Centre on the Bay of Bengal coast, carrying the PSLV C-42 mission payload into a 583-kilometre-high Sun-synchronous orbit. The mission includes the 444-kilogram Surrey Satellite Technologies-built S14 optical high-resolution Earth observation satellite. It's designed for surveying resources and environment and for disaster management. The second satellite in the payload is the 445-kilogram Novasar-1, also manufactured by Surrey Satellite Technologies. It's designed to test an S-band synthetic aperture radar platform which will image land use and ice cover as well as provide disaster and maritime management telemetry. Novasar-1 will be jointly used by the UK Space Agency, Australia's CSIRO, and the Indian Space and Research Organisation. The launch was India's 4th orbital mission for 2018 and the 44th flight of a PSLV rocket. India's next flight, well actually there'll be 2 of them, both in October, one using a PSLV, the other using the GSLV. Actual launch dates are yet to be finalised. Australia's new fledgling space agency has signed their first major international deal. The agency's teamed up with its French counterpart, the CNES. The new partnership will see the French working with the University of New South Wales and the Australian National Concurrent Design Facility to develop technology for future space missions. The head of the Australian Space Agency, Dr. Megan Clark, has described the Memorandum of Understanding with Paris as the first step of the new agency's journey with fellow spacefaring nations. Clark says the new agreement will explore advanced space technology and applications used for Earth observation and remote sensing, using high-altitude balloons and satellites, as well as space operations and joint ventures. The federal government allocated $41 million in seed funding to establish the new space agency. The global space industry is currently worth over $420 billion annually, with that figure expected to climb to around $3 trillion by 2030. Fleet Space Technologies has opened its South Australian ground station at Redbanks Reservoir. The facility at Pinkerton Plains complements mission control consoles at Fleet's headquarters in Beverley and Adelaide's West, which will be tracking and communicating with orbiting spacecraft planned for launch by American and Indian rockets over the next few months. The first, a pair of nanosatellites named Centauri 1 and 2, are planned for launch in October. The first aboard an Indian Space Research Organisation rocket from the Satish Dhawan Space Centre, and the second aboard a SpaceX Falcon 9 from the Vandenberg Air Force Base in California. The spacecraft are the first of a new constellation designed to support mining operations, precision agriculture and isolated rural farms in Tasmania, maritime monitoring in the middle of the Pacific Ocean, and food supply chain management in Asia. I'm Stuart Gary. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a Science Report. New research shows a mixed picture of Australia's sexual health, with overall HIV diagnoses at a 7-year low. But the findings by the University of New South Wales show the drop was mainly among gay and bisexual men, with HIV diagnoses increasing by 10% among heterosexuals over the last 5 years. The study also shows HIV diagnosis rates in the Indigenous population are twice those of non-Indigenous people. A world-first study into the marine ecological impact of a large-scale water desalination plant shows it's not having a major impact on the local environment. The 6-year study on the Sydney desalination plant by the University of New South Wales looked at the effects of pumping and diffusing the high-concentration salt water back into the Pacific Ocean. The research comes at a time of increasing reliance on desalination plants for drinking water across most states in Australia, as drought conditions worsen and domestic water supplies decline. The study examined 6 underwater locations at a depth of about 25 metres over a 6-year period, during which time the plant was under construction, then operating, and then sitting idle. This enabled researchers to monitor the impacts and recovery among marine life from the effects of pumping large volumes of hypersaline water into the ocean. The findings show the main effect was limited to a small area within about 100 metres of where the outflows were located, and were most likely the result of changes in water flow. As well as Sydney, desalination plants operate in Melbourne, Adelaide, Perth, the Gold Coast, and many remote and regional locations. Globally, about 1% of the world's population now depends on desalinated water for daily use. A new study warns that by 2060, deep ocean reefs in cooler waters of southeastern Australia are likely to be substantially different, becoming more tropical in response to ocean warming. Researchers found that while subtropical reefs are likely to move further south, for other ecosystems now inhabiting the cooler waters along places like Tasmania's south coast, there's nowhere further south for them to go. The findings, reported in the journal Nature Climate Change, warns that Tasmania provides the very last refuge against ocean warming. The research mirrors similar studies taken over the past decade. It shows that climate-driven ocean warming will produce deep reef communities unlike anything surrounding Australia today. There's another glint of hope for the, shall we say, follically challenged, with new research claiming the smell of sandalwood may well help stimulate hair growth in human scalp tissue. A report in the journal Nature Communications claims researchers have found that molecules that create sandalwood smell don't just trigger receptors in your nose, but it turns out the outside of hair follicles like the smell too. They found that applying synthetic sandalwood odor molecules on samples of human scalp stimulated hair growth by reducing cell death and by boosting the production of growth factors in the hair root. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter Twitter through @StuartGary, at SpaceTime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.